All right. So section 3.1 is on differentiation laws. And first of all, let's remember the formal definition of a derivative, right? So we have the function y equals f of x. And the formal definition of derivative f prime of x is the limit, right? The limit as h goes to 0 of the difference quotient f of x plus h minus f of x over h, okay? So that is the formal definition of the derivative f prime of x, okay? For the function f of x. Now, so technically speaking, every time you differentiate, right, this is what you got to do, okay? I think that's the projector. So I'll go ahead. No, it's not gonna. I just turned it off because we're not using it today because I'm lecturing. Okay, from not from a handout. Okay, so it sounded like it was gonna blow up. So every time you find a derivative of a function, right? This is the formal definition of the derivative of f of x. Okay. Fortunately, mathematicians way back when, using this definition of a derivative, found patterns in differentiating different types of functions. Okay, so we have formulas for differentiating certain types of functions, and that's what we're doing today. Okay, so just like there were limit laws, right? There are differentiation laws or different rules of differentiation. Okay, so the first one, and all these rules, technically you should be able to prove using this definition, right? So the first one is the derivative of a constant function. And so we have f of x is equal to c, okay? Where c is any real number. And oh, I forgot, before I shut down, I forgot to put it up. But remember yesterday we talked about Leibniz notation and function. We're going to be mixing it all up today, okay? We're going to be using a lot of Leibniz notation with function notation, okay? Well, the derivative of a constant c with respect to x, remember this is derivative with respect to x, okay? The derivative of c with respect to x in Leibniz notation is equal to 0. And that makes sense because the graph of f of x equal to c is a horizontal line. And what's the slope of a horizontal line? 0. The slope m of a horizontal line is 0. Okay. So here in my coordinate plane, and I'm going to draw it so that c is a positive real number. Right. Here is the line y equals c, right? So the graph of f of x equals c is the horizontal line y equals c, and the slope m is equal to 0 of a right. The slope of a horizontal line is 0. So remember, the derivative gives us the slope of the curve at each f prime of x is the slope of the curve at each value of x. Well, the slope of a horizontal line at each value of x is 0. Okay? So this intuitively makes sense. Okay? So if f of x is equal to 10, then f prime of x, which is equal to the derivative of 10, right? The number 10 with respect to x is equal to 0. Right? So the derivative function f prime of x is just equal to 0. Okay. If we have y equals 2 pi, what's pi equal to? Yeah, 3.141, right? From trigonometry. So if y, so this is like 6 point something, right? 2 times pi is like 6.28, blah, blah, blah. So if y is equal to 2 pi, then the derivative of y, so we're using Leibniz notation, right? The derivative of y with respect to x is equal to the derivative of 2 pi with respect to x, which is equal to 0. Okay? So the derivative of a constant, okay, with respect to whatever variable is always equal to 0. Okay. The next is called the power rule. If n is any real number, then the derivative with respect to x of x to the n power, okay, is equal to, now there's one thing about these rules of differentiation, there are patterns. And it's the patterns you want to remember. Okay, that's what makes it easier. Okay. So the derivative of x to the n with respect to x, you bring the exponent n down in front of the x, and then you subtract 1 from the exponent. So derivative of x to the n with respect to x is n times x to the n minus 1 power. Okay. Now, and we're covering this in my pre-calculus classes, or we just did a couple of days ago. Okay, f of x equals x to the n, right, is called a power function. And that's why this is called the power rule, because you're differentiating the power function. Okay. So let's do some examples. We have f of x is equal to x squared, right? So you should recognize that's a power function with n equal to 2. And you should recognize that as a squaring function. Its graph is a parabola that goes through the origin. Okay. The derivative of f of x, f prime of x, right, is equal to, in Leibniz notation, the derivative of x squared with respect to x. Derivative of x squared with respect to x, you bring the 2 down from the x, and you subtract 1 from the exponent, and you have 2 times x to the first power. So if f of x is equal to x squared, then f prime of x is equal to 2x. if g of x is equal to x to the 99th power, then g prime of x, right, the derivative of g of x, is equal to the derivative of x to the 99th power with respect to x, which is equal to, you bring the exponent 99 down in front of the x, and then you subtract 1 from the exponent. So the derivative of x to the 99th power is 99 times x to the 98th power. Any questions on that pattern? Okay. Next we have h of x is 1 over x to the 8th power. So if h of x is equal to 1 over x to the 8th power, then what's h prime of x equal to? Is h prime of x equal to 1 over, bring the 8 down in front of the x and subtract 1 from the exponent? Is that how you find that derivative? Or do we have some work to do before we can find the derivative? Because it has to be in the power function, has to be in the form of x to the nth power, right? And that we don't have that here. So 1 over x to the plus 8th power is equal to x raised to negative 8, right? The minus sign in the exponent means reciprocal. Okay? X to the minus 8th is 1 over x to the 8th. So now we can differentiate this. So h prime of x is equal to the derivative of x to the minus 8th power with respect to x. And now we use the definition of the power rule. You bring the minus 8 down in front of the x, and then you subtract 1 from the exponent. So h prime of x is equal to minus 8 times x to the minus 9. And typically, if this was a test question, right, you could stop right here. But if you want to take it a step further, you can write it as the answer is minus 8 over x to the 9th power. Both are acceptable. Okay. Now, if you're finding the equation of a tangent line to this function for some value of x, it would probably be in your best interest to write it this way before substituting in for x. Okay. All right. So far, so good. Okay. Next, we have y is equal to the square root of x. So if y is equal to square root of x, then the derivative of y with respect to x, before we find derivative, we have some work to do. How do we rewrite square root of x? Yep, x to the 1/2. We're also, we just covered rational power functions in my pre-calc class, right? Rational power functions, the exponent of the variable x is a fraction. Okay. Yeah, so x to the 1/2 means square root of x. Okay. So now this is in the form of a power, right? Rational power function. So we can apply the power rule. The derivative of y with respect to x, you bring derivative of y with respect to x is equal to the derivative of x to the 1/2 with respect to x. Okay. And now using the power rule, you bring the 1/2 down in front of the x, subtract 1 from the exponent. And if this was a test question, you could stop right here. Okay? But if you were finding the equation of the line, the equation of the tangent line, some value of x, you may have to rewrite this as 1 over 2 times x to the 1/2. Which is equal to 1 over 2 times the square root of x. Because x to the 1/2 equals square root of x. Okay? So all three answers are acceptable. Okay? Which one you choose to give is up to you. Okay? All right, so any questions on that, ladies and gentlemen? Okay. The next rule is called the constant multiple rule. And it says if C is a constant, and when we say a constant, we're saying C is a real number. Any real number. So if C is a constant, and the function f is a differentiable function, then the derivative of C times f of x, okay? So we got the real number C times the function f of x is equal to, what can I do with this real number C? You guys remember? Yeah, I can pull it out in front of the derivative. It's a C is a multiplicative constant. I can pull it out in front of the derivative. This is equal to C times the derivative of f of x with respect to C. This is equal to C times the derivative of f of x with respect to x. Okay? So you can just pull, just like with limits, you could, if you had a C was a multiplicative constant, you could pull it out in front. You can do the same thing here. Okay? So let's do some examples. We have y is equal to 3 times x to the 4th. Now, you know with the limit laws, when we were evaluating limits, you didn't have to write out all the limit law of each step in finding the limit, right? You didn't have to write out all the different limit laws. You did them up here mentally. Same thing's going to happen here, okay? We're going to demonstrate the rule of differentiation, but when you're actually working homework and answering quiz questions and exam questions, you're not going to write out all these steps. You're just going to go ahead and take the derivative. And it's implied that you're applying the rule. Okay? So we have y is equal to 3 times x to the 4th. So the derivative of y with respect to x, okay, is equal to the derivative of 3 times x to the 4th with respect to x. Okay? And by this constant multiple rule, 3 is just a multiplicative constant. I can pull it out in front of the derivative. And so this is equal to 3 times the derivative of x to the fourth with respect to x. Okay. Well, this is a power function. So we use the power rule to differentiate x to the fourth. So we have 3, right? Derivative of x to the fourth is 4 times x cubed, right? By the power rule, bring the 4 down in front of the x, subtract 1 from the exponent, and then 3 times 4 is 12. Okay. So this is the application of this rule. But on an exam, if I asked you to find the derivative of 3x to the fourth, right, everybody would be able to jump right down the final answer. Okay? You wouldn't have to write out the middle 2 steps. I'm just demonstrating this rule. Okay? All right. If f of x is equal to 6 times the cube root of x squared. Okay? So this is 6 times the cube root of x squared. Okay? Then f prime of x is equal to what? Well, before we differentiate this, do we have some work to do? Yeah, we got to rewrite the cube root of x squared, right? What's the cube root of x squared? How do we rewrite that as x what? Raised to what power? 2/3, right? 2 is the exponent, 3 is the root. So this is equal to 6 times x to the 2/3 power. Two is the exponent on the variable x, and 3 is the root. And so whenever you have the nth root of x to the m power, that's x to the m over n power. Okay, we're doing this. We did this in pre-calculus just a couple of days ago. Okay, so now we can differentiate f of x, right? F of x is 6 times x to the 2/3, and so 6 is a multiplicative constant. So the 6 can be brought out in front of the derivative. So we have 6 times the derivative of x to the 2/3. And now you can apply the power rule to x to the 2/3, right? Bring the 2/3 down in front of the x, right? The 6 is just a multiplicative constant. Bring the 2/3 down in front of the x, and then subtract 1 from the exponent. 2/3 minus 1 is equal to negative 1/3. Now, on the next exam, you'll be given a gazillion functions to differentiate. Okay, and typically I write you don't have to simplify. Okay, sometimes you do, but if I'm just testing you on the rules of differentiation, typically you don't have to simplify. Okay, so but 6 times 2/3 you should recognize is equal to 4. So we have 4 times x to the minus 1/3. Okay. Let me stop right there. Okay. Good review of fractions, eh? All right. Any questions? All right. the next rule is called the sum rule. If f and g are both differentiable, then, so now those of you, right, so in pre-calculus, college algebra, right, high school algebra, you probably learned, if you have two functions, f of x and g of x, you can create a third function by adding them together, those two functions together, subtracting one from the other, multiplying them, dividing. And the fifth one is taking the composite of the two, okay? So if f and g are both differentiable, then the derivative with respect to x of the sum of the two functions, right? So f of x plus g of x is the third function, okay? Well, the derivative of that sum is the sum of the derivatives. It's equal to the derivative of f of x I don't like that. It's the derivative of f of x plus the derivative of g of x with respect to x, okay? So as an example, so what this says is if we have a function with a sum of two or more terms, we can differentiate that function term by term. Okay? So as an example, we have y is equal to 3 times the square root of x plus 2 over x cubed. So 3 times the square root of x is a function, 2 over x cubed is a function. So we have a sum of two functions. And so finding the derivative of y with respect to x, right? The sum rule says we can differentiate this first function with respect to x and then the second function with respect to x. Okay? Well, we got some work to do before we can differentiate though, right? We have y square root of x is x to the 1/2, and 2 over x cubed is 2 times x to the -3 power, right? Now we can differentiate. The derivative of y with respect to x is equal to the derivative of 3 times x to the 1/2 power with respect to x plus the derivative of 2 times x to the -3 power with respect to x. So this, right, we use the constant multiple rule, right? Now I'm not going to actually, we've already done the illustration, right? But I can bring the 3 out in front of the derivative and then multiply it by the derivative of x to the 1/2 with respect to x, and the derivative of x to the 1/2 using the power rule with respect to x. You bring the 1/2 down front of the x, and then you subtract 1 from the x bar. So the derivative of this with respect to x is 3 times 1/2 times x to the -1/2. Okay. In the second function, 2 is a multiplicative constant, so I can bring it out in front of the derivative. And now I take the derivative of x to the minus 3 power with respect to x. And using the power rule, I bring the minus 3 down in front of the x. And then subtract 1 from the exponent. Minus 3 minus 1 is negative 4. 3 times 1/2 is 3/2. 2 times minus 3 is negative 6. So the derivative of y over here with respect to x is equal to 3/2 times x to the minus 1/2 power minus 6 times x to the minus 4th power. Okay. Are you with me? Okay. So we're just applying these rules. Okay. And again, if this was a test question, after you rewrote this, right? When you differentiate, you probably go from here to here and then simplify the coefficients, okay? The multiplication and the coefficients, okay? All right. Well, we have the sum rule, so there's got to be the difference rule. Sometimes these rules are written together. Your textbook doesn't do that, okay? So if f and g are both differentiable, then the derivative with respect to x of f of x minus g of x is equal to the derivative of f of x with respect to x minus the derivative of g of x with respect to x. Okay? So all I did was change the plus sign to a minus sign. Okay? So this says if you're taking the difference between two functions, the difference or the derivative of the difference in the two functions is equal to the derivative of the first function minus the derivative of the second function. Okay. So I have g of x is equal to 4x cubed, so this is a quotient, 4x cubed minus 5x squared plus 3x plus 10 divided by x. Now there is a rule called the quotient rule, but we haven't learned it yet. Can we differentiate this function with the rules we've defined up to this point? The short answer is yes, or I wouldn't put it on the board, right? Mm-hmm. So we got some work to do, right? Anybody want to guess what work we have to do? We can divide each of these terms in the numerator by x, right? Just like you did on the exam and finding the limit, right? You divide top bottom by x, okay?
But the 10 doesn't
have an x. Huh?
The 10 doesn't have an x, so.
Oh. Doesn't. So we'll have 10 over x, right? And we can handle that situation, okay? All right, so before we find g prime of x, we got some work to do, okay? So this is equal to 4x cubed over x minus 5x squared over x plus 3x over x plus 10 over x. Do you agree with me? We're adding and subtracting terms, so each of those terms got to be divided by the denominator, x, right? Well, 4x cubed over x simplifies to 4x squared. minus 5x squared over x simplifies to minus 5x. 3x over x simplifies to plus 3. And then 10 over x is the same as 10 times x to the minus 1 power. Right? Now we're using both the sum and the difference rule simultaneously to make this interesting. Okay? So by the sum rule and the difference rule, in finding the derivative of g of x, we can differentiate each of these terms separately. Okay? So g prime of x, so if g of x is equal to that, then g prime of x is equal to the derivative of the first term minus the derivative of the second plus the derivative of the third plus the derivative of the fourth. Okay? So now remember, I'm not out to embarrass anybody. Okay? But I like class participation. So Taylor Moore, you were the lucky one, right? The last time. Okay. So Anna Motel, are you here?
Yes.
So you're not gonna differentiate the whole thing. We're just gonna term by term, right? So g prime of x is equal to the derivative of the first term minus the derivative of the second plus the third plus the derivative of the fourth. Okay? So Anna, what's the derivative of 4x squared? 8x. Kenneth, what's the derivative of minus 5x?
Minus 5.
Eric, what's the derivative of plus 3 with respect to x?
0.
Yeah, it's 0. And Nikki, where you at, Nikki? Is Nikki here? Nikki must be the one. All right. So now we've taken attendance. Gwen, where you at, Gwen?
Here.
What's the derivative of 10 times x to the minus 1 power?
Negative 10x to the negative second power.
There you go. Okay? So it's minus 10 times x to the minus 2 power. And so getting rid of the 0, that's the derivative. Okay? Very good. And then if you wanted to, you could write this as minus 10 over x squared. Okay? Very good. All right. One more. H of x, maybe we'll do it over here. H of x is equal to x plus 2 times x minus 1. Now that's actually a product of two functions. You can think of it that way, right? This is the first function, the second. And there is a rule called the product rule, okay? But we haven't learned it yet, okay? So, but we can differentiate this thing. We got some work to do before we can differentiate it. What do we got to do? Foil. Very good. Because this will actually foil into a quadratic, right? So when we foil this guy, you multiply first terms, you get x squared. When you do outer, you get minus x. When you do inner, you get 2x. 2x minus x is plus x. And then when you do last terms, you get minus 2. So h of x, right, after you FOIL, is equal to the quadratic function x squared plus x minus 2. So h prime of x, the derivative of h of x, using the sum rule and the difference rule. Who did I last call on? Gwen?
Yeah.
So Jenna, just give us, what's the derivative of x squared?
2x.
Well, give us the whole derivative. What's the whole derivative?
2x plus 1.
Yeah. Derivative of x squared is 2x. Derivative of plus x is plus 1, and the derivative of the constant minus 2 is 0. Now I've had, between over 3 days, I picked on everybody in the class, so you can all feel equally picked on. Okay? All right. Let's do one more, and then we'll call it the weekend. So we have f of x is equal to 7x cubed minus 3 over cube root of x squared plus 2x plus 5 squared. Can we differentiate that function with what we know so far?
Yes, sir, it wouldn't be up there.
Huh?
Said yes, sir, it wouldn't be up there.
Yes, sir, it wouldn't be up there. Okay? But we got some work to do first, right? This is like an exam. I mean, I'm doing nice examples, but they're a little more interesting on the exams, right? So this second term, we got to rewrite as minus 3 times x. The second term was written as minus 3 times x raised to what power? Negative 2/3. Very good. Okay? Does everybody see that? Okay? Because 1 over the cube root of x squared is equal to 1 over x to the plus 2/3, which is equal to x raised to the minus 2/3. Okay? And then we have plus 2x. And what's the last term equal to? Is that x squared? What's 5 squared equal to, ladies and gentlemen? That's all that is. Don't let it fool you. Okay? Yeah. That's 25. Okay? If f of x is equal to that, then f prime of x is equal to derivative 7x cubed. 7's a multiplicative constant. Bring the 3 down in front of the x and subtract 1 from the exponent, right? So we have 7 times 3x squared. Then we have minus 3, right? That's a multiplicative constant. Now we use the power rule to differentiate x to the minus 2/3. You bring the minus 2/3 down in front of the x. And then you subtract 1 from the exponent. Minus 2/3 minus 1 is negative 5/3. And then take the derivative of plus 2x, which is just plus 2. And then you know the derivative of a constant is 0. So now when you clean up the coefficients, 7 times 3 is 21. And then minus 3 times minus 2/3, negative times negative is positive. 3's cancel. And we're left with plus 2 times x to the minus 5/3 power. And then plus 2. So f prime of x, the derivative of f of x, is equal to 21x squared plus 2 times x to the minus 5/3 plus 2.